Hello everyone and welcome to the channel. Back to computer vision applications. Today we have a very interesting one. We'll be building a simple computer vision application for skin cancer classification as either benign or malignant, like this one. We will be using a dataset of more than 11,000 images from both classes to train a convolutional neural network. Then we will use another dataset of 2,000 images to test and evaluate our model. So let's see how to do this. So first we need to import some libraries that we will need. So we need to import OS, operating system. This is to access our local files. We need to import NumPy to do some numerical operations and to work with arrays. And also from TensorFlow Keras, we need to import the image data generator. This is to load our images from the local file. And also from TensorFlow Keras models, we need to import the sequential model. This is to build our neural network. And from TensorFlow Keras layers, we need the 2D convolutional layer, the max pooling layer, the flatten layer, and the dense layer. We will talk about this later. And finally, we need to import matplotlib to do some visualization. Let's run this, and this is okay. Now let's define a path to access our images from a local folder. So the base directory here is a path to the local folder where I'm keeping all my images, which is the cancer detection, this folder here, and it contains two subfolders, the test and train, and each one of them contains two subfolders, the benign and malignant, and each one of them contains a set of images. So the base directory is the path to this folder here where I'm keeping both the test and train images. Next, I want to define a train directory, which is a path or a directory to only the train folder, which is this folder here. And I want to join all images in this folder, the train folder, from the two subfolders, the benign and malignant, into one directory named the train directory. So all images in these two folders will have one directory named the train directory together with their classes. So for each image, I still should be able to know if this image is belonging to the benign folder or the malignant folder. So the train directory is a directory for all images in the train folder coming from either the benign folder or the malignant folder. Next, for each image, I want to rescale the pixels to have a number between 0 and 1. We know that for any image, all pixels contain a number between 0 and 255. Here we are dividing this number by 255 in order to scale this number, the pixel number, to be between 0 and 1. Why we are doing this? Because neural network can be trained efficiently and can work efficiently with the rescaled data or rescaled images. Lastly, the train generator. We are now ready to retrieve our images using the flow from directory. So from the train directory, we are going to retrieve all our images, resize them to have a size of 150 by 150, and each 20 images will be retrieved as one batch. So the batch size is 20. So each 20 images are retrieved together, and the class mode is binary. So for each image, it's going to belong to one class. It's either 0 or 1. 1 is for malignant and 0 for benign. So if the image belonging to the subdirectory, which is malignant, is going to have a class or a label of 1. If it is belonging to the benign the subdirectory or folder or class, it's going to have a label of 0. So if we run this, we can see that 11,879 images have been retrieved and belonging to two classes, which is these two classes, these two folders. If we take a look here, we can see that the benign folder contains 6,289 images, and the malignant folder contains 5,590 images, which is matching to this number here, which is 11,879 images belonging to two classes, which is the benign and malignant classes. And as we said, each one is now having a label, 1 for malignant and 0 for benign. Now let's quickly plot an image from each class. So class labels is a variable that contains the two labels from the train directory here, which is the benign and malignant labels, sorted alphabetically and stored in the class labels. And then from the train generator here, give me the next batch of images, the next 20 images together with their labels, and then create a plot which is 10 by 6, and then loop through the class labels here, which contains only two labels, benign and malignant. So I is going to be 0 and 1, and this loop will be executed only twice, and create a subplot that is only one row, and the number of plots is 2 because the length of class labels is 2. And when I is 0, that's going to be the first plot, and show me the first image when I is 0. and set the title of the plot to the class name. So if the image is coming from the benign class, the title will be benign, and if it is coming from the malignant class, the title name will be malignant, and set the axis, the y and x axis, to off because we are plotting images, so we don't need the x and y. And if we run this, we can see here that this image is coming from the benign class, and this image is coming from the malignant class. Now we are ready to build our neural network. So from TensorFlow Keras, we are using sequential model, which means the layers will be connected in a sequential way, in a linear way. The first layer is a 2D convolutional layer, which is having 32 filters. Each filter is of a size 3 by 3. The activation function is ReLU. The input shape is 150 by 150, which is an image with 3 colors because we are working with colored images. The second layer is a max pooling 2D max pooling layer of a size of 2 by 2, and then a flattened layer. So the image will be flattened into 1D vector connected to a dense layer of 512 neurons, and the activation function is ReLU. The dense layer means it's a fully connected layer, so all neurons in one layer connected to all neurons in the next layer. And the last layer is the output layer, which is a dense layer of 1 neuron, which is the output classification, and is going to be either 0 or 1 if it is benign or malignant. And the activation function is sigmoid. Don't be concerned too much about the details here because I will make another video to explain this in details. What is the convolutional layer, what is max pooling layer, what is flattened, what is dense, and what is the activation functions. For now, you can think about it something like this. So there is input image, there is a convolutional layer and max pooling layer. So these two layers are for feature extraction, and then connected or flattened and connected to a hidden layer, a fully connected layer, and then to the output neuron, which is in our case only 1 neuron. Here it's 4 neurons because this image is just from Google. So for now, you can think about it like this. We have 2 layers for feature extraction and 3 layers, flattened, hidden layer, and output layer for the classification. Next, we want to configure the training process. So the loss function is binary cross entropy. So this is a commonly used function when we work with classification problems. This is to measure the difference between the predicted class and the actual class of the image. And the optimizer we are using is RMS prop. You can use different optimizers like Adam in order to improve the performance of the model. So the optimizer is the one responsible to change the weights on the neurons in order to optimize and reduce or minimize the difference between the predicted class and the actual class. So to minimize the error, in other words. And the metrics is the accuracy. This is how we evaluate the performance of the model during the training process. And lastly, we are ready to train our model using the train generator, which includes our images, the training images, which we have prepared already. And the steps per epoch is 100, and the number of epochs is 15. What is the number of epochs? This is how many times we go through the entire dataset. And in each epoch, we use 100 patch of images or patch of data. And the purpose is just if you want to show the progress bar during the training process or not. So we are ready to train our model. We can see now here that the training is in progress. This is going to take some time, between 10 minutes and 20 minutes. Now we can see that the training is finished in 11 minutes. And 15 epochs are done and 100 steps in each one. Now let's go ahead and plot the accuracy versus the loss. There is nothing special here, it's just plotting. So from our result, we are plotting the accuracy in blue, and similarly, we are plotting the loss in red, and the rest are just labels. So let's go ahead and run this, and now we can see during the training process, 15 epochs, the accuracy in blue was improving and the loss was decreasing. Now let's test our model using the test images. The same way we did with the train images, we set a test directory to the test folder, and we join all the images in that folder coming from the 2 subfolders, the benign and the malignant, into one directory, which is the test directory. And then we rescale all the images, all the pixels in the images, to have a number between 0 and 1, and then create a test generator. And we are ready to retrieve our images using the flow from directory, which is the test directory. and then resize all images to have a size of 150 by 150, the batch size to be 20, and the class mode to be binary, which is 0 and 1 for malignant and 0 for benign, and set the shuffle to false so that the images are retrieved in the same order that they are found in the folder. And lastly, we pass the images from the test generator to the model to evaluate and return the test accuracy and the test loss and print the accuracy and the loss. So let's go ahead and run this. 2000 images belonging to two classes. If you want to double check this, so this is the test. So if we go to this subfolder, we have 1000 images. And if we go to this folder, is 1000 images. So 2000 images belonging to two classes, which is the benign and malignant, which is correct. And now the evaluation is done. So the performance of the model is the accuracy of 84%, which is quite good. Now, last thing to do is to build a simple app to select an image from a local folder, to pass it to our model, which we have trained already, and then to make prediction and show the prediction on the app. So let's go ahead and do this here. So we need to import Tkinter library. This is to build the app. And also from Tkinter, we need to import the field dialog. This is to open a local folder and to select an image. And also from PIL, this is a library that is for image processing. We need to import image and image decay. And then we need to define image size. So for any image that we will select, we need to resize it to be 150 by 150 because we trained the model on this size. So it has to be matching. And then we define this function here. So this function will be executed every time we push a button to select a folder or a file or an image. So it's very easy. When you execute this function, it will go and open a field dialog to select an image and return the path to that image if you selected an image. And then it will open that image from that specific path and resize the image to be 150 by 150, and then pass the image to the image label that we will define here. Oh, what is this? Okay. Then it will pass the image to the label, to the image label that we defined here to display the image inside that label. And here we have the button that we will push to execute this function. And the name of the button is open image. So every time you push this button, it will go and execute this function to select an image and to display it in this label. And these two lines here is to create the app, to create a window, and to give it a name for the app, which is skin cancer detection. And lastly here is to run the app. So it's very simple. We just push this button here. It will execute this function to select an image, resize it, and display it in this label. So let's go ahead and run that. So this is the app, and then when we select an image, it will be displayed in the app. Now let's see how to pass this image to our model and to display the prediction on the app. So first thing we need to do is to add a function here to pass the image to the model to predict. And the output of the model will be a probability between 0 and 1. And remember that in the beginning we assigned 1 for malignant and 0 for benign. So we will pass an image, make a prediction, the outcome will be between 0 and 1, and then if the prediction is more than 0.5, it will be malignant, and if it is less than 0.5, it will be benign. So that's what will be the return out of this function. So we pass an image, make a prediction, check what is the output of the model. If it is more than 0.5, it will return malignant. Otherwise, it will be benign. So that's the first thing we need to do. Next, we need to add something here to pass the image that we have displayed. So the outcome of this function is an image that has been displayed in this label here. So we want to make a few lines of code here to take that image and pass it to this function to make the prediction. So we will take the image from here and we will divide it by 255. Remember that we trained our model on a rescaled image so that the pixels are between 0 and 1. So we want to do the same here. We want to rescale the image first to make a prediction. So we take this image, divide it by 255, and then save it in the variable image, and then expand the dimension of the image, and then pass this image to the function that we have created here to make a prediction. So we just took the image from here, process it using these two lines of code, and then pass it to this function to make a prediction and to return the prediction into a variable called result variable. So this variable here we have defined here result variable, so to hold the prediction result from this line. Once we have a prediction, we want to create a label where we will display our prediction. So here we create a label, and then the font will be red, and the size of the font will be 14 and is bold. So this is the configuration of the label. And what the text will be displayed in this label is the result variable, which we have defined here, and which is holding the result out of the prediction. So let's go ahead and run this. Now we can see that we have a prediction. So the predicted class is benign. So we have passed an image, and the label is here to hold the prediction. We can double check and go back and choose from the malignant. You can choose this one, and you can see that the prediction is here. So that is it. You can make this a little bit bigger, and then you can see here the name of the app. So that's the end of the video. Thank you very much for watching.